Hi guys, welcome to my channel. Today, we are going to talk about on how to solve rational inequalities. So to make it easier for you to understand our discussion, we're going to solve certain examples step by step. On the first example, we have 2x over x plus 1 greater than or equal to 1. So the first step that we're going to do is to rewrite the inequality as a single rational expression on one side of the inequality symbol and 0 on the other side. So let's move 1 on the other side of the inequality here, and let us write the inequality as a single rational expression. So we're going to have 2x over x plus 1 minus 1 greater than or equal to 0. So let us simplify this one. Let us write x plus 1 on the denominator. Then x plus 1 divided to itself is 1. Multiplied by 2x is 2x. Then let's multiply negative 1 by x plus 1. So, negative 1 times x plus 1 greater than or equal to 0. Next, let's have 2x. Then let's multiply 1 by x, that is negative x. Then negative 1 multiplied by 1 is negative 1. So let's write negative 1 over x plus 1 greater than or equal to 0. That. The next step that we're going to do is let us equate x minus 1 to 0 together with x plus 1. So let's have, so x minus 1 is so x is equals to 1, and then next is x plus 1 to 0, so x is equals to negative 1. Then let's draw a number line to check whether negative 1 and positive 1 is included in our solution. So let's draw here a number line with negative infinity on the left side and then positive infinity on the right side. Then let's write negative 1, then positive 1. Since the inequality symbol of our equation is greater than or equal to, it means that the value of this expression must be positive, because all positive numbers are greater than 0. So let's say x equals positive 1. So we are going to have x minus 1 over x plus 1 greater than or equal to 0. Let's substitute all x in the equation to 1. So 1 negative 1 over 1 plus 1 greater than or equal to 0. So 0 divided by positive is positive. So positive greater than or equal to 0. So positive is greater than or equal to 0, so it is true. Therefore, positive 1 is included in our solution. So let's shade it. Let's put a circle, and then shade. There. Now let's try x equals -1. So we have x minus 1 over x plus 1 greater than or equal to 0. Now let's substitute all x to -1. So -1 over, so this is -1 plus 1 greater than or equal to 0. Now we have negative. So if you add these two, it turns out to be negative over 0 greater than or equal to 0. So negative divided by 0 is undefined, and undefined is not greater than or equal to 0. So it is not true. So I'm going to encircle the -1, but won't shade it because -1 is not included in our solution. So the next step is, let us check which of the following range is included in our solution. So I'm going to rewrite the number line. There. So let's start here. So these three are the range. So let's start with this range. Let us have a number less than -1. Let's say -4. Okay. So x minus 1 over x plus 1 greater than or equal to 0. So we're going to substitute -4 to all x. -4, okay, greater than or equal to 0. So -4 minus 1 is negative, and -4 plus 1 is negative. So negative over negative is positive. So this solution is true. So I'm going to shade this part to indicate that this region is included in our solution. Next, this range. Let's have 0. So 0 minus 1, 0 plus 1, greater than or equal to 0. So we're going to have negative over positive. So negative over positive is negative, which turns out to be false. So we are not going to shade this part. Next, let's go to this range. We're going to have 4, positive 4. So 4 minus 1 over 4 plus 1 greater than or equal to 0. So positive over positive greater than or equal to 0 equals to positive. So it is true. So I'm going to shade also this part. This time, we are going to figure out if we're going to take the positive intervals or the negative intervals. Now, we are given the greater than or equal to 0. It is our clue that we are only going to take positive intervals. So the first thing that we're going to do is let's write first our values. So it's going to be negative infinity to negative 1 and positive 1 to positive infinity. This time, we are going to find out of which of the endpoints should be included and should not be included. Always remember that all infinity should not be included. So, we're going to put open and close parentheses. So, I put open parentheses in the negative infinity since it is not included, and close parentheses in the positive infinity because it is not included also. Now, let us look at negative 1. I'm not going to include negative 1 because it is not included in our solution. Next, let's put union of bracket. Why did I put bracket? Because positive 1 is included in our solution. So, how are you going to read this? We're going to read this as solution set equal to open interval from negative infinity to negative 1 union of half open interval from positive 1 to positive infinity. Now, let's have another example, a much harder one. Let's say we have 1,600 over x minus 4 greater than or equal to 1,120 over x minus 2. So, the first thing that we're going to do is to rewrite the inequality as a single rational expression on one side of the inequality symbol and 0 on the other side. So, let's move 1,120 over x minus 2 on the other side of the inequality, and let us write the inequality as a single rational expression. So, we are going to have 1,600 over x minus 4 minus 1,120 over x minus 2 greater than or equal to 0. Like what we did before, we're gonna put these all together, but we need to find a common denominator first. So, I'm going to multiply this rational on the top and bottom by x minus 2, and this one on the top and bottom by x minus 4. So, we're going to have 1,600 times x minus 2 over x minus 4 times x minus 2 minus 1,120 times x minus 4 over x minus 2 times x minus 4 greater than or equal to 0. Now, let's go ahead and put the numerators together. So we're going to have 1,600 times x minus 2 negative 1,120 times x minus 4 over x minus 4 times x minus 2 greater than or equal to 0. Now, We are going to simplify the numerator, so we're going to distribute in our 1,600 and negative 1,120. So it's going to have to be 1,600 times x is 1,600 x. Then 1,600 times negative 2 is negative 3,200. Next, negative 1,120 times x is 1,120x. And negative 1,120 times negative 4 would be positive 4,480 over x minus 4 times x minus 2 greater than or equal to 0. Now we're going to combine similar values. So we have 1,600x minus 1,120x. It would give me 480x. And negative 3,200 plus 4,480 would give me positive 1,280 over x minus 4 times x minus 2 greater than or equal to 0. Now, our next step is we're going to find out their x values. Let's start with 480x plus 1,280. So we're going to write it in 480x plus 1,280 equals to 0. So I'm going to transpose 1,280 on the other side. 480x equals negative 1,280. And then I'm going to divide both sides with 480. That would eliminate our 480 on the left side. So now we're going to have x is equals to negative 8 over 3. So that is the value of x on the 480x plus 1,280. Next, we're going to find the value of x of our x minus 4. So we're going to have x minus 4 equals to 0. So x is equal to positive 4. Next, we're going to have x minus 2 is equal to 0. So it will be x is equal to positive 2. This time, we are going to draw a number line to check whether our negative 8 over 3, positive 4, and positive 2 is included in our solution. So let's put negative infinity on the left side and then positive infinity on the right side. Since the inequality symbol of our equation is greater than or equal to, it means that the value of this expression must be positive because all positive numbers are greater than 0. So I'm just going to write our values here. So negative 8 over 3 and 2, 4. Now let's find out if these values are included in our solution or not. Let's have first the x is equal to negative 8 over 3. So we're going to have 480 x plus 1,280 over x minus 4 times x minus 2 greater than or equal to 0. Now, we're going to substitute all x in the equation. So, it's going to be 480 times negative 8 over 3 plus 1280 over minus 4 times negative 8 over 3 minus 2 greater than or equal to 0. Now, we are going to have 0 over positive greater than or equal to 0. So 0 divided by positive is 0 greater than or equal to 0. So since 0 is equal to 0, so this solution is true. So I'm going to encircle negative 8 over 3 and I'm going to shade it to indicate that it is part of our solution. Next, let's have positive 4. So x equal to 4. So we're going to substitute plus 1280 4 minus 4 times 4 minus 2 greater than or equal to 0. So we are going to have positive over 0 greater than or equal to 0. So positive divided by 0 is undefined. Greater than or equal to 0. So it is false. Next. So I'm only going to encircle positive 4, but I won't shade it because it is not part of the solution. Next, let's have positive 2. So x is equal to 2. We are going to substitute again. So 480 times 2 plus 1280 over 2 minus 4 and 2 minus 2. 0. This time, you can choose any value that you want as long as it is within this range. So let's start here. Let's say we have x is equal to negative 5. So let's have negative 5 here. So let's substitute it. 480 times negative 5 plus 1280 over negative 5 minus 4 times negative 5 minus 2 greater than or equal to 0. So we're going to have negative over positive greater than or equal to 0. So negative divided by positive is negative. So it is false. So this range is not included in our solution. Next, let's go to the second range. Let's say we have positive 1. So we're going to have x is equal to positive 1. Then let's substitute. 1 plus 1280 over 1 minus 4 1 minus 2 greater than or equal to 0. So we are going to have positive over positive greater than or equal to 0. So positive divided by positive is positive. So it is true. So I'm going to shade this part since it is included in our solution. So I'm just going to use this marker. There. Now, let's go to our third range. Let's say we have positive 3. So, I'm going to write, then substitute. Let us substitute all x. So we are going to have positive over negative greater than or equal to 0. So positive divided by negative is negative greater than or equal to 0. So that is false. So we are not going to shade this part. Next, let's go to this range. Let's have positive 10. So I'm going to have x is equal to 10. So we're going to substitute. So we are going to have positive over positive greater than or equal to 0. So positive divided by positive would be positive. So it is true. So I'm going to shade this part since it is part of our solution. There. Now, let us write our answer in interval notation. First, let us write our values first. So we're going to have negative 8 over 3 to positive 2, and then we have positive 4 to positive infinity. So that would be negative 8 over 3 to positive 2 and positive 4 to positive infinity. Since we are given with greater than or equal to 0, it means that the value that we are going to consider in our solution would be all positive. So, now let us find out which of these endpoints should be included and should not be included in our solution. So remember, every time we deal with infinity, we must not include it. So let's put parentheses. Now let's check this h one by one. So negative 8 over 3 is included in our solution, so I'm going to place a bracket in it to indicate that it is included. Now, let's look at positive 2. It is not included in our solution, so I'm going to put close parenthesis and then union of. So 4 is not included in our solution. as you can see here. So I'm not going to include it, so I'm just going to put parenthesis. Now, how are we going to read this? We're going to read this as solution set is equal to half open interval from negative 8/3 to positive 2, union of open interval from positive 4 to positive infinity. If you are going to follow these steps carefully, I am absolutely sure that you're going to be able to solve all of your rational inequality problems easily.